All right, so homework 37, we're starting out converting rectangular coordinates to polar coordinates. And on our polar coordinates, you want to have the magnitude of your vector, or the radius, and then you want to have the angle of your two lines that's in there. Again, just to remind you, you are going to need this sheet here where you can look up your inverse tangents like we've done before. And so you want to make sure you have that sheet handy. If you don't have that sheet handy, find it. We just used it on the previous homework page. So going back over here, in polar coordinates, our polar coordinates are going to be r, which is going to be the size of your line, and an angle. So if I draw my rectangular coordinates, x is -4, y is -4 square root of 3. So I'm down here in quadrant 3. I want to find the r value. In other words, I'm finding the size of that line using my Pythagorean theorem. R is equal to the square root of a squared plus b squared. So I'm going to have the square root of -4 squared plus -4 square root of 3 squared. So -4 squared we know is 16. -4 square root of 3. If I take -4 square root of 3 times the second -4 square root of 3, I get a positive 16 square root of 9. So that makes that 16 times 3, which gives me 48. 16 plus 48 is 64. So I have the square root of 64, which is just 8. So my polar coordinate, the first value is going to be the 8. I would go 8 to the right. Now I need to find the angle that I have to go around. So for my angle, again thinking of this angle here, I have to do the tangent. So I am going to do the inverse tangent of the opposite over the adjacent. So -4 square root of 3 over -4. -4 square root of 3 over -4. Those cancel out, so I'm doing the inverse tangent of the square root of 3. Now I can see over here that I'm in quadrant 3. So looking at my paper for the angle, for quadrant 3, inverse tangent of square root of 3 is 240 degrees. So 240 degrees is going to be my other measurement. And so -4 and -4 square root of 3 in polar coordinates would be 8 and 240 degrees. So number 2, my rectangular coordinates are at -3 square root of 3 and +3. So this time I'm over here in quadrant 2. R is the square root of -3 square root of 3 squared plus 3 squared. So if I take -3 square root of 3 times the second -3 square root of 3, I get +9 square root of 9. Square root of 9 is 3. 9 times 3, 27. I get 27 when I square that. 3 squared is 9. So 27 plus 9 gives me the square root of 36, which is just 6. So in my polar coordinates, my first value is going to be a 6. I then need to find my angle. Using my inverse tangent, my opposite over my adjacent. So 3 over -3 square root of 3 would reduce down. I'd have 1 over square root of 3 if I rationalize that. Square root of 3, square root of 3. I get inverse tangent of, this is going to be negative, square root of 3 over 3 then, right? Have the square root of 3 over the square root of 9, which makes it square root of 3 over 3. I am in quadrant 2. So in quadrant 2, I'm looking for inverse tangent of negative square root of 3 over 3. So if I look there, I have 150 degrees if I look at my table. So my polar coordinates would be 6 with 150 degrees. Number 3. My rectangular coordinates, I would be doing the square root of 3, which is positive, minus 1, which is negative, so I'm going to be down there in quadrant 4. R is going to equal the square root of 3 squared plus negative 1 squared. This would give me the square root of 9, which is 3. This would be 1. 3 plus 1 is 4. The square root of 4 is 2. So in my polar coordinate, 2 is going to be my first value. My angle, I am going to do the inverse tangent of the opposite over the adjacent. So negative 1 over the square root of 3. Again, I have to rationalize my denominator. So I'm going to have the inverse tangent of negative square root of 3 over 3. This time I'm over here in quadrant 4. So looking in quadrant 4, inverse tangent of negative square root of 3 over 3 is 330 degrees. So this is 330 degrees. So my polar coordinate would be 2 and 330 degrees. 4, 5, and 6 are converting from polar coordinates to rectangular coordinates. This is R, this is the measure of your angle. So if I'm thinking about this, this is R, this would be X and Y. So if I'm looking for X, I would use the cosine because I have the adjacent and the hypotenuse. So I would say that the cosine of theta equals X over R. Solving that for X then, X equals R times the cosine of theta. Same kind of thing with the Y. Here I have the opposite over the hypotenuse, so I would say the sine of theta equals Y over R. So Y is going to equal R times the sine of theta. So I'm just basically going to use those two formulas in order to figure out my rectangular coordinates instead of my polar coordinates. So the X value in my point is going to be R times the cosine of theta. My Y value is going to be R times the cosine, or not the cosine, the sine of theta. So in this case, the R is the negative 3. That's already there, that first value in my polar coordinate. So I'm going to have negative 3 times the cosine, and here's my angle, 5 pi over 4. Here I'm going to have negative 3 times the sine of 5 pi over 4. And once again, I'm just going to use my table that I have. So make sure you have your table handy, and you're just going to look up what is the cosine of 5 pi over 4. 5 pi over 4, I get negative square root of 2 over 2. So I'm going to have negative 3 times negative square root of 2 over 2. Here, I'm going to have negative 3 times the sine, which is also negative square root of 2 over 2. So, multiplying this out, a negative times a negative is going to give me a positive 3 square root of 2 over 2. That's going to be my X value. Here again, negative times a negative is a positive 3 square root of 2 over 2. And so my rectangular coordinates in this case, I get 3 square root of 2 over 2 and 3 square root of 2 over 2. So number 5, again, to find my X value, I'm going to take R times the cosine of theta. To find my Y value, R times the sine of theta. So in this case, this is my R value, this is theta. So I'm going to take 2 times the cosine of negative 11 pi over 6 and 2 times the sine of negative 11 pi over 6. Now on our table, we don't have negative measures, so we have to change that to the positive measurement. So if I were at negative 11 pi over 6, I'm just going to take 2 pi minus 11 pi over 6 and change it to the positive measurement. So 6 times 2 would give me 12 pi over 6 minus 11 pi over 6, which is just pi over 6. So I'm really going to do 2 times the cosine of pi over 6 and 2 times the sine of pi over 6. So looking at my cosine of pi over 6, pi over 6. My cosine is square root of 3 over 2. So 2 times square root of 3 over 2. And my sine is 1/2. 2 times 1/2. So here the 2's cancel out. I get the square root of 3. Here the 2's cancel out. I get 1. So my coordinates would be square root of 3 and 1. So my rectangular coordinates there, I get the square root of 3, positive 1. And number 6, same kind of thing. X is going to equal r, which is negative 3, times the cosine of my angle, 2 pi over 3. Y is going to equal negative 3 times the sine of my angle. In this case, I have a positive angle, so I can just look those up. So negative 3 times the cosine of 2 pi over 3. 2 pi over 3 would be negative 1/2. Here I have negative 3 times the sine of 2 pi over 3, which is the square root of 3 over 2. So here I'm going to have a negative times a negative, a positive 3/2. Here I have a negative times a positive, so I have negative 3 square root of 3 over 2. So my rectangular coordinates, 3/2 goes in for my x value, negative 3 square root of 3 over 2 goes in for my y value. So converting from my polar coordinate to my rectangular coordinate, I'm using the r value, which is your first value, times the cosine of your angle, and then the sine of your angle. If this angle isn't a positive angle between 0 and 2 pi, then you've got to convert it into the equivalent angle between 0 and 2 pi. All right, 7, 8, and 9, we are graphing an ellipse. General form of ellipse is x minus h squared plus y minus k squared over a squared b squared equals 1. So you can see a little bit, it sort of resembles the equation for a circle with the x minus h squared and y minus k squared, where the center of my ellipse is going to be at hk. Then what you're going to have is your distance from the center to the outside of your ellipse is going to be the square root of your a squared and the square root of your b squared. If this number is bigger, your ellipse is going to open up from left to right longer. If this one is bigger, it's going to go from top to bottom longer. Not that you really have to know that, but this is going to be from the center to the edge of your ellipse. And same thing here. So I'm looking at my general form of my equation, and notice again, just like in a circle, since these have minuses in, when you do the center, it's going to be at the opposite of these things. So if x minus 4 equals 0, x would equal 4. If y plus 4 equals 0, y would equal negative 4. And therefore 4 and negative 4 are going to be the center of your ellipse. So if I go to 4, negative 4, 1, 2, 3, 4, I would be down here. Then what I'm basically doing is taking the square root of this number and the square root of this number. The square root of 9 is 3. Since this is under here, I'm going to go to the right, 3. 1, 2, 3. And also to the left, 1, 2, 3. Under the y, I'm going to do the square root of 4, which is 2. So that's going to be your up and down. So I'm going to go 1, 2 up and 1, 2 down. And my ellipse is going to sort of look like that if I could draw it. So because this number underneath my x was bigger, it is longer going left to right than it is up and down. If we look at number Okay, so on number 8 again, we're graphing the ellipse, and just to remind you, standard form, x minus h squared over a squared, y minus k squared over b squared equals 1. If the a squared is bigger, it's going to open up longer. If the b squared is bigger, then it's going to be taller and go that way. So in this case, we have x minus 1 squared over 36 plus y minus 1 squared equals 1. Keep in mind here that if we made this a fraction, that this would be over 1. So if I'm picking out my center doesn't want to quite right where I think it's going to. Since I have x minus 1 and y minus 1, both of those are going to be at the opposite of what they're going to be, since I have a minus here in my formula. So my center is going to be at 1, 1. Since a squared equals 36, a is going to equal the square root of 36, which is 6. Since b squared equals 1, b equals the square root of 1, which is 1. So my center is at 1, 1. Over 1 and up 1 is where my center is going to go. A, I'm going to open up 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then B is 1, so up 1 and down 1, and my ellipse is going to look something sort of like that. Number 9. Again, if I look for my center is going to be at a positive 3 and a positive 1. So 1, 2, 3, 1. Now notice on this one, this value is smaller than this one is, so this one's going to be taller than it is wide. But the same thing you're doing. I'm going to take the square root of 4, which is 2. So I'm going to go 2 to the right and 2 to the left. Here I'm going to do the square root of 36, which is 6. So I'm going to go 6, 1, 2, 3, 4, 5, 6 up, and 1, 2, 3, 4, 5, 6 down. And this time my ellipse is going to look something sort of like that. I'm going to pause the video here for a minute so I can hop on Alex so I can show you the tools you're going to use when you're drawing an ellipse. So on Alex, when you're going to graph the ellipse, here's the ellipse tool here. Obviously, it's a little different than the circle tool, but works in the same way. First of all, you found your center, and on this one, the center is at 4, 5. And then in the x direction, you're going to go 3 units. In the y direction, you're going to go 2 units because the square root of 9 is 3 and the square root of 4 is 2. Of course, when I go use the tools, my writing will probably come off of there, but I'm going to go ahead. And if I grab my ellipse tool, which is this one here, I'm going to click on my center. So I'm going to go to 1, 2, 3, 4, and then 1, 2, 3, 4, 5. I'm going to click to place the center. Now I'm going to first of all place my vertex going to the right and left. I'm going to go 1, 2, 3 places. That's going to open that up here. Then I also have to do the co-vertex, which is the up or down, which is 2. And so I go back here, I go up 2, and so my vertex was 3, my co-vertex was 2, and now I have my ellipse drawn. Just quickly one more time. I'm going to grab my ellipse tool. I'm going to place the center at 4, 5. I'm then going to do the vertex first, which is my right or left. So I went 1, 2, 3, and clicked. And then my co-vertex, which is my up or down, so I went up 2 and clicked. And there's what my ellipse looks like. (10, 11, and 12 are graphing our ellipse that is going to be centered at the origin. If it's going to be centered at the origin, what we want to get this back into in standard form. So you'll notice in standard form your equations always equal to 1. So whatever we have over here, we're going to divide everything by. So in this case, I'm going to divide by 400, divide by 400, divide by 400. So on the top, I'm going to be left with just an x squared. And on the top of the other one, I'm going to have a y squared, and it's equal to 1. So 400 divided by 16, if I grab my calculator, 400 divided by 16 would give me 25. 25 divided by 400, guess what? It's probably 16, huh? 16. So we won't have any parentheses on the top, which means we have a plain x squared and a plain y squared, that my center is at 0, 0. Well, by the name, centered at the origin, hopefully you already knew the center was going to be at 0, 0. So here I'm going to do the square root of 25, which means I'm going to open up 5 for my vertex. The square root of 16 is going to be 4 for my co-vertex. So again, I'm going to place the center. I'm going to go 1, 2, 3, 4, 5 to the right, which also opens it up 1, 2, 3, 4, 5 to the left. I'm going to go 1, 2, 3, 4 up, which is also going to go 1, 2, 3, 4 down for my co-vertex. And my ellipse is going to be centered around the origin. My vertex was 5, my co-vertex was 4, and so my answer looks something sort of like that if I could draw an ellipse. So really the whole thing you're going to do is just divide by whatever your n number is to get it into standard form, and then do it like we did the previous problems. So on number 11, we're going to divide by 16. So we're going to have x squared over 16 plus, this is going to be 1, so just to remind you, it's y squared over 1 equals 1. Again, my center is going to be at the origin, so at 0, 0, and then the square root of 16 is 4, and then the square root of 1 is 1. So I center it at 0, 0. I go 4 to the right, which also opens it up 4 to the left for my vertex. I go 1 up, which also opens it 1 down for my co-vertex. And my ellipse looks something sort of like that. Number 12. This one I'm going to divide by 100. So I'm going to have x squared over 25, nope, over 4. 25, or 100 divided by 25 is 4, plus y squared over 25 equals 1. So 100 divided by 25 went in there 4 times. 4 goes into 125 times. Again, my center is going to be at the origin, so at 0, 0. This time I'm going to have the square root of 4 is 2, and the square root of 25 is 5. So I centered it at 0, 0, opens up 2 to the right and left, opens up 5 up and down, and so my ellipse is going to be taller up and down than it is wide, since my bigger number was under my y, and it's going to look something sort of like that. All right, 13, 14, and 15, this time we're graphing a hyperbola. A hyperbola looks sort of like this when you're done. It's either going to go this way if the x squared is positive, or going to go this way if the y squared is positive. So in general form, if my x squared is positive, I'm going to have x minus h squared minus y minus k squared over a squared b squared equals 1. Notice for a hyperbola we have a subtraction in here instead of an addition like we did on the ellipse. Same type of thing happens when I solve this. My center again is at hk. So my center is going to be at 3, 5. Square root of 25 is going to be 5. That's going to go right and left because it's under the x. The square root of 16 is 4. That's going to be the up or down since that's under the y. So what's going to happen is you're going to first of all place the center which is at 3, 5. Then you're going to go the x direction first. Since the x is positive, you're going to move over 5. 1, 2, 3, 4, 5 for your vertex. It's going to say draw the rectangle. You're then going to go 1, 2, 3, 4 up. 1, 2, 3, 4. What's going to happen? 1, 2, 3, 4, 5. 1, 2, 3, 4. On Alex, it's going to draw this box in here like this. And it's going to have the diagonals drawn through the box, if I could draw straight. And my ellipse is going to open up left and right. So my ellipse is going to go like this, or my hyperbola is going to go left and right. So my hyperbola is going to open up like that. So you'll place the center, and if your x is first, means you're going to go 5 to the right, 4 up. It's going to draw that box in there, and it's going to draw your hyperbola going to the left and to the right. If I clear that and hop over on Alex for fun, if I look at my Ellipse tools, on this one, notice my x squared is first. So my center is going to be at 2, 5. So going to 2 and up to 5. These ones hop by a half, so you have to be careful that you're at 2, 5. Now my vertex is going to go 5 to the right since that's under my x. So I'm going to end up over here at 7. If I get that in the right spot. My y is going to go up 4. 1, 2, 3, 4. So it says place the rectangle. Only be careful, don't do what I just did. I counted 4 clicks, but these are each going up by a half. So if I'm at 5 and I want to go up 4, I should end up at 9. So make sure you get your thing. I always double check here once it's drawn and you can see, you can count better. 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4 up. Yes, I have the right rectangle. And then it just automatically draws your hyperbola in there for you. It says I did it correct. So if I go back over here to number 14, number 14, notice that one is the other way around. The y squared is first. That tells me it's going to go up and down. Now my center, when I do this, I'm still thinking at y minus k squared and x minus h squared. So when I do my center, the h is with the x, the k is with the y. It's just the way it's going to open up and down is different. So when I look at the center of this one, my center is going to be -4 with the x, 0 with the y. So -4, 0. So at -4, 0, I'm going to have my center. Square root of 16 is 4. That's going to be the up or down first. The square root of 9 is 3. That's going to be your right or left. So I'm going to go 1, 2, 3, 4 up, which also is going to show 1, 2, 3, 4 down. I'm going to go 1, 2, 3 to the right, 1, 2, 3 to the left, and my rectangle is going to look something sort of like that. So on Alex, when you draw that, you have to do the 4 up first, then draw the rectangle by going 3 to the right, and your hyperbola is going to open going up and down, sort of like that. So again, if I hop over to the Alex program, notice on this next one, the y is first. So when I do my center is going to be at -5, +4. The x first and then the y. So -5, +4 would be right there. Again, just move it over to the edge so you can see you were at -5, +4. Now I'm going to do my y first. So to place my vertex, the square root of 25 is 5, so I got to go up 5. 1, 2, 3, 4, 5. I was at 4, should be at 9. That looks good. Placing my rectangle then, Remember, that would be over 1. The x plus 5 squared would be over 1. So I'm going to go 1 to the right. And so I'm just going to double check that. I went 1, 2, 3, 4, 5 up, 1 to the right, and my hyperbola is going up and down because my y's were first. It doesn't want me to click check. I must have to check with the with my mouse. Maybe it's just really slow. So if I check that, it says, yep, that's good. So going back over here on Alex on number 15, or on our notes number 15, this one my x is first. So I know it's going to go open up to the right and to the left. My center will be at 3, 5. Square root of 25 is going to be 5 to the right. Square root of 16 is going to be 4 up. So my center would be at 3, 5. 3, 1, 2, 3, 4, 5. I'm going to go 5 to the right. 1, 2, 3, 4, 5. And 3 up. 4 up. Square root of 16 is 4. I didn't even write that. 4 up. 1, 2, 3, 4. 1, 2, 3, 4. That is going to draw a rectangle on Alex with the diagonals through the center. Since I did the right direction first, my hyperbola should open up to the left and to the right. So if the x squared is positive, my hyperbola opens up left and right. All right, 16, 17, and 18, we're graphing a hyperbola, which is going to be centered at the origin. And like on the ellipses, we're going to end up dividing by the end number, but on these ones, they're going to make us move the number over first. So this should be a positive 225. I'm then going to divide by my 225. 25. Since I want this in proper order, since the y squared is positive, that's going to be the one that's first. So I'm going to have y squared over 225 divided by 25 is 9, minus x squared over 25 divided by, or 225 divided by 9 is 25 equals 1. This is the one that's going to go up and down since my y squared is positive. Square root of 9 is 3. Square root of 25 is 5. So center on all of these is at the origin. 0, 0. We don't have any parentheses on the top. So we center it at 0, 0. I'm going to go 3 up. 1, 2, 3. Which also means it's going to go 3 down. And then open my rectangle. 1, 2, 3, 4, 5 to the right. 2, 3, 4, 5 to the left. So my rectangle looks something like this. And my hyperbola is going to go up or down. So it's going to look something like that. So on number 17, same kind of thing. I'm going to move my 36 to the other side. I'm going to divide by 36. And again, my y squared is positive, so I'm going to switch my order. So y squared over 36 divided by 4 would be 9, minus x squared over 36 equals 1, right? 1 divided by 36 is still 36. So, square root of 9 is 3. The square root of 36 is 6. We're going to go up and down first. And so my center, again, is at the origin, 0, 0. I'm going to go 3 up. 1, 2, 3 up. 3 and 6 to the right. 1, 2, 3, 4, 5, 6. Which is going to make my rectangle look something sort of like this. And my hyperbola should be opening up and down, since my y squared was positive, and it's going to look something sort of like that. One last one on this page. Number 18, again, we are going to do a hyperbola, which is centered around the origin. I'm going to move my 16 over and divide by 16. This time my x squared is positive. So I'm going to have x squared over 16 divided by 4 is 4, minus y squared, 16 divided by 1 is still 16, equals 1. So I'm going to have the square root of 4, which is 2, which is going to go right and left first, and the square root of 16, which is 4, that's going to be my up or down. So since my x squared is positive, we know it's going to go to the left and to the right when we have our hyperbola. So center again, going to be at 0, 0. It's at the origin. So my center's at the origin. I'm going to go 2 to the right first, and then I'm going to open my rectangle by going 4 up. My rectangle is going to look something sort of like this. My hyperbola should open up to the right and the left, and so it's going to look something sort of like that. So, ellipse has a plus sign in the middle. Hyperbolas will have a minus sign in the middle. The ellipse, you don't have to worry about the order so much. You just look at what's under the x and what's under the y. But on the hyperbola, if the x squared is positive, it's opening up to the right and to the left. If the y squared would be positive, it should open up and down. And when you place your vertex, you have to do that direction first for it to draw right on Alex.